Demand for energy are growing rapidly over the past decade due to economic growth, population expansion and industrialization of developing worldwide. This scenario causes mismatch between supplied energy generated and consumption demanded. Therefore, energy storage is implemented to ease intermittent power disruptions by storing excess power generated by renewable resources at time of low demand and distributing in periods of high demand. Lithium-ion battery, one of the most widely used and efficient energy storage in the world. It is a better energy storage compared to others in a short period of time due to its efficiency and lower costs. However, in long period of time, more and more batteries need to be built and this causes the cost become very high. Thus, lithium-ion battery is not a favorable energy storage to overcome the overflowing of energy. A large-scale salt cavern, a salt dome which stores large amount of hydrogen gas underground can overcome this issue because hydrogen gas can store in underground for long periods of time at low cost and save large area of land space. How does the hydrogen storage work? A very large electrolysis system that will be able to convert renewable power into hydrogen is built and then hydrogen is stored in the salt dome for a long period of time so that when we need to use energy, the hydrogen can be forced to flow out to move the turbine to generate electricity, supplied to hydrogen fuel cell and also transport through pipelines for domestic heating purposes. These are the few ways to convert hydrogen into energy. However, the most effective way is to use hydrogen as fuel in fuel cell to generate electricity. This is because fuel cell is efficient and mechanical ideal due to there are no moving parts where chemical energy is directly converted into electrical energy. If we compare to lithium-ion batteries, it is not as cost-effective as hydrogen in a long period of time. This is due to lithium-ion batteries will only be able to withstand 500 to 1000 charge-discharge cycles before their capacity falls. Besides, the materials needed in cathodes to pack in more energy are often expensive because metals like cobalt, nickel, lithium, and manganese need to be mined, processed, and converted into high-purity chemical compounds. For hydrogen storage, hydrogen gas can be stored underground which is extremely economical in terms of land area. More and more lands can be saved for other fields developments. Since hydrogen gas is the least dense molecules in the world, it is very bulky and eventually increase the cost of transportation. However, transporting hydrogen gas through pipelines is likely to be cost competitive because hydrogen can flow through a pipe nearly 3 times faster than natural gas. This eases the transportation of hydrogen gas to hydrogen fueling station for vehicles and fuel cell power station to generate electricity to grid. Hydrogen is highly flammable and will combust at low concentrations. Therefore, safety issues have to be highlighted so that we can use hydrogen as energy storage safely. In salt cavern, salt formations are almost perfectly impermeable. Underground, hydrogen are separated from the oxygen in the air which is necessary for combustion by several hundred meters of rock. This same natural barrier protects them from fire, willful damage and aircraft impact. High storage pressures present no problem so far as high pressure is the natural state of the fluids underground. Besides, pressure relief devices must be installed along the pipelines, hydrogen fueling stations and fuel cell power station in order to maintain the hydrogen pressure in a safe condition. For the environmental impact, hydrogen can be made with zero carbon emissions from water and renewable energy sources. Thus, the use of renewable technology rather than fossil fuel able to combat against the environmental problems such as global warming, air pollution and greenhouse effect by providing sustainable, clean and efficient energy, free of harmful pollution or greenhouse gas emission. Moreover, as a fuel, it can act as a decarbonization solution for those sectors that would struggle to transition to electricity use. If we use hydrogen gas as fuel source in fuel cells such as proton exchange membrane fuel cell, the only waste product is water which is clean and safe. According to the Managing Director of Research of BOFA Securities, Chaim Israel.
If we are serious about decarbonization, if we are serious about going into a world which has zero carbon emission, there is no choice but using hydrogen.
Overall, hydrogen not only can solve the energy storage crisis in future, it can also provide us a green and sustainable world by using renewable technology to produce hydrogen. In future, the use of hydrogen is expected to totally replace fossil fuel in electricity generation and energy storage so that we can have a better and cleaner world.